for 2020, nice and positive. So we'll continue to support Carleton. We're going to upgrade the 21 centimeter dish to a 2.5 meter dish like we have for the pulsar array. That will be not a huge bit of work. The mount that we already have will be adequate. We have to tweak a few things, but that'll improve our sensitivity and give us higher resolution.
Feed blockage will go down too.
Yes, feed blockage will go down, yes. Although the feed blockage at the moment is not that bad. Pulsar work, we're going to continue to work on RFI remediation, both in terms of shielding the control room and investigating new algorithms to try to deal with the RFI, and hopefully actually successfully detect the pulsar that we're looking for. Try to get the IDEA project off the ground again. This is the project that I had talked about a couple of years back, which is a collaborative effort to detect atomic deuterium around the NCP, the North Celestial Pole, because the idea behind having people point at the NCP is not because it's super scientifically interesting. It's just that you don't need to move your dish. You don't have to track anything. Everybody just points at the NCP. Your dish is going to have a fairly sloppy resolution, so it's going to be imaging a field around the NCP, and you just get the integrated power from the deuterium line, which is weak. It's about, I think the ratio is about 10,000 to 1. So for every hydrogen atom up there, or for every 10,000 hydrogen atoms, there's maybe 1 deuterium atom, and the density of hydrogen atoms is like 2/3 of nothing. So it's a long-term project, long-term integration, that kind of thing. But it would be cool if amateurs could detect the deuterium line, reliably. So there's a paper on the website about it, and we were hoping actually to put an IDEA station up at FLO and have one here, so at least we had 2 of them, and then having 2 of them operational, maybe people would get on board and build their stations and so on. Everybody pointing at the NCP means, there's no real pointing required, no tracking, none of that. You just kind of integrate all day long the deuterium line. Also, we're looking at deploying a mini chime here. I don't know how many of you are familiar with the Chime Observatory out west. It's one of the largest radio telescopes in the world now of its type. So we're thinking of building a miniature version of that here, initially just pointing it straight up and looking for FRBs ourselves, fast radio bursts, which are one of the new darling objects of the astrophysics community. And the brighter ones should easily be detectable with a mini chime. So maybe 15 to 20 feet across and about 30 feet long, which is actually doable. A group like us can actually build something like that. And shouldn't be that hard, he says.
No, not at all.
I forgot the bullet for add more blinking lights.
Oh yeah, well that was a late addition. So just imagine here, more blinking lights. And there we go. We actually did build a sort of a prototype chime-like antenna a year ago, I think. I built it over there, and it was like 8 feet by 20 feet, a parabolic trough, and it was way more work than I thought it would be, like a spectacular amount of work. But that taught us some things about the methodology we should use to actually build a bigger one. So we're hoping to do that sometime in the coming year.
Is there a way you can protect it to keep the snow and rain and stuff off of it?
Well, if you use lower frequencies, you can have a relatively coarse mesh, and the snow won't accumulate as badly.
Okay.
Yeah. But it's all Chime has the same issue.
Yes.
I'm not sure how they deal with it, but they have exactly the same issue. Their mesh is actually quite fine, considering that they only cover 400 to 800. The mesh they use is actually fairly fine, and they do get heavy snowfall there from time to time. So
Heaters or blowers or something?
maybe, or really a lot of grad students and
Interns with brushes.
Yes. Well, apparently the big dish there, the 85-foot dish there, it gets snow on it, right? And the method for clearing it off is to approach it from behind and whack it with a hammer, right? And this sets up this oscillation that goes on for minutes, and it tends to shake all the snow off, usually in one big go, like an avalanche. So the way they test the IQ of their grad students is they tell them to go and clear the snow off the big dish, and they only tell them you gotta whack it. So some grad students have, had to be dug out of the snow. That's what they're for, right? Isn't it?
Building care.
So I think that's it for the presentation part. Now we can move on to do a bit of a tour if people want. I can't take you guys up to the roof for lots of different reasons, but just assume that it's there and there's a dish up there that you've seen in the pictures.
That's
Okay.
for the summer barbecue.
That's right, we'll have our summer barbecue up there, yeah.
You guys get great satellite TV, I imagine.
Well, everybody asks that, oh, you must get great TV reception. It's like, well, I guess theoretically